Late, streamer is late. Hello there. Alright, we finished shader view yesterday. So, this is now Alright, so now if you go to the website, GLSL.com, you can go to shader view, you can download it. So let me show this off. Boom. Oh, wait. There we go. Alright, hold on. I'll be right back. I gotta do something quickly. Alright, let's start. So what we're going to be doing today, we're going to be working on this new C library I've been working on called C-Core. So just to show some of the syntax here, this is actually is based on a lot of Strand Engine's code. So you can see here, like the stream, read, write. It's just a lot more organized version of that. So what we're going to do today is we're going to write some examples, some of this code, and we're going to write some more functions for the stream class here, like a stream serialize using a reflection, and we might write random number generator or another part of this. But the main part we're going to be finishing is the socket and the WebSocket part. So I want to use this for my Fatfish online game server, so that basically if I'm going to end up using this much nicer code that I feel much better about maintaining, I don't want to write the server using this old code. So we're going to push ahead and try and get the socket and server stuff done for this, so that we can use that. But I also like to write examples as I go along with this, so I'm going to change this to test ground from Hello World, because this is really what I'm using to test around with. I think we're just gonna go ahead and create a new Visual Studio project for this. Weird how this is going. I don't know. Whatever. So we actually want the solution to be the same folder, so I think we're just gonna do this. I hope this works. I hope it didn't create two folders, a hello world and a hello world. No, it created them in the same folder. Yes! That's what we wanted. Okay. I'm going to delete all these because we're doing everything basically header only. One file is going to be main.c. We're going to open that up in gedit. Alright, here we go. So part of this C core includes an entry point macro. Right here, entry point. So this handles loading the launch arguments and things, and that way you don't need to worry about writing win_main. So actually the first thing we need to do is include C core. One of the things we could do, we could go in here and we could change that to an additional include directories. We can add that, but we're not going to do that because I like doing relative paths much better. It's much easier, then you don't need to do basically any setup. Just make a new project. Oh yeah, and I forgot that Visual Studio doesn't support 64-bit builds straight off the bat. Oh, that's amazing. So I guess we're just gonna keep it like that. Anyways, entry point. And, hello world. Print hello world to console, and then we're also going to print back out the launch arguments. Signed, unsigned mismatch. Wait. Oh. Is that an int? And 32. Is it because, oh yeah, okay, whatever. Oh yeah. One of the things that I like to do is I like to just turn the release folder just into the project folder. Just like that. Oh wait. Never mind. It's supposed to be, I guess, just a slash. Guess it's solution then. Fatal error cannot open. Not properly set up. I don't know why. Why doesn't this work? Hold on, let's try restarting this. That cannot open file. Hello world.exe. That's so weird. Oh my god, it worked. And dot dot. Why does dot dot slash work? Okay, what is the proper directory for this? Target path, I think project dir. Yes, that is it. There we go. Alright, so this hello world. I think I'm gonna create probably a buffer example next. Buffer from string. I think we're going to use in this example the index of index of functions. Find first index of L. I think it's memory index of, not buffer index of. Oh yeah, it's just index of. We're going to output the index, and we're going to output the string. Find the last index of L. Now we're going to do the same thing with the last index. Oh, it's length instead of size. Yeah, so there's some stuff where I used to call length, and that I've now called size. First occurrence of L at hello world. Last occurrence of L at... Oh, I'm outputting the wrong variable here. First occurrence of L at... Last occurrence of L at negative 2020. Okay, there is something broken there. This is why I test this. Oh, okay, so the start index for this needs to be positive. Why does this return negative 2020? That's broken. This is supposed to return negative 1. While I minus 1 equal to 0. That shouldn't be negative 2020. Try casting this. Oh, that needed to be cast. Because it was subtracting unsigned, this was looping around, I guess? Okay, so now this needs to be string buff. We can actually do this though. We can do if start index equals 0, return negative 1. But anyways, we start it at string buff.size. So it's going backwards. And then there we go, last occurrence of L. I'm going to print out something. There we go. Alright, I'm happy with that buffer example. Now we're going to do an array example. That's going to be a little bit more complicated. I'm not sure how though. I don't know if we'll do... I don't think we'll do another index of... Maybe we might just show adding and removing elements. Alright, hold on. I gotta change this music. This music is way too slow for me right now. Yeah, so we're going to construct, we're going to create a dynamic array. And then we're going to add in, we're going to remove hello world and replace it with goodbye world to show inserting and removing. Alright, now remove hello from array. I think there's a remove n. Remove n. insert goodbye. Oh no. We don't need this anymore. Oh, that didn't work. Interesting. Oh my god, this is supposed to be n size bigger than... Hello world, goodbye world. There we go. That is the array example. I just delete all these extra files so that it takes up as little space as possible. Alright, what's the next example gonna be? I don't know if I'll do one for the I guess I'll do one for the multi-threaded array. I don't know if I want to do one for reflection or multi-threaded array. I'll do system info right now, actually, because this will just be... I saw a big bird go by my window. This will just be printing like what the CPU supports. Hold on, I want to go and look outside. I do not know. Maybe that was a hawk. Oh. So a dove just flew right up on my windowsill. Oh my god. Wish I could point my camera up there. listing. Alright, we're going to turn this into a macro. Oh man, you know what? So this is an example. You actually don't want to reduce written code. Oh man, but you know what? It's also at the same time, it's good to provide an example of how you can use macros like this. Oh man. Okay. So ID is also going to be the feature name, so we can turn it to a string like this. And do S like that. Or that it does system GPU supports ID underscore ID, and then if it is, then we do supported. Otherwise, we do not unsupported. That makes it clear it's not available. Unavailable. Alright. Printing features supported. So this is going to be a lot. I'm just going to try this to start to make sure our macro works. Okay, but it does work. Sweet. So we can just go ahead and write this for all the other features. So this is why I made a macro for this, because this would take absolutely forever to write otherwise. I'm basically copying all the feature names from here, and then the macro is automatically querying these, and at the same time printing out the name, so I don't need to write the name here twice. And I thought this might be too complicated for an example, but I mean CPU features like this are complicated in the first place, and I think it's good to show people how to use macros like this. Even if people think macros are evil and unorganized. God damn, there's so many AVX 512 instructions, or instruction sets. Start copying these AVX ones. That's got an A in front of it. Is that an error, or is that actually... No, there's no A in front of it. I just don't think so. Wikipedia CPU features. No, yeah, that's actually a mistype on my account. There we go. Well, now it's fixed. Alright, that should do it. Listing 8 processing units of CPU. Listing supports CPU features. MX support, SSD supported. A2 supported, SC3 support, FMA support, DCA supported. SC41 unavailable, SSE42 supported. OVE support, AS supported, OSX save supported. Wait, SSE41 unavailable? Do I have that bit wrong? Hey, DMA Tech. Oh my god. Wait. I think maybe my processor just expects that we'll query for 4.2, and then if 4.2 is supported, then 4.1 is also supported, because like I'm so confused. How does it support 4.2 instructions and not 4.1? What? up. 80 divided by 32. 16. Reserved. Oh shit, I got this wrong. That wouldn't make sense. So there would be software code for 4.1, 4.2. Yeah, no, I'm sure it's an error on my part now. I'm pretty sure I have these bit offsets wrong. So look and make sure. So SSE is at 0, 64, which is correct. Use multiply add is actually 12 down, which is wrong. Yeah, where did I get these offsets from? Plus 12, 76. So this is 76 instead of 73. This is 82. Oh my god, wait. So that's 3 off. That's 3 off. All of these are 3 off. Oh. Okay. So yeah, all of them going down to here. 3 off. Bitwise. Oops. Well, that's easy to fix. Just add 3. Alright, let's check this last one. 30 plus 64. It is correct. Okay, we got it now. Okay, I knew something was wrong there when it said that SSE4.1 is unavailable. It's actually good I caught that. I wonder if AVX2 isn't even supported, and that's just wrong. MX supported, 4.1 supported, DCA unavailable. Yeah, I actually thought DCA was unavailable. AVX2 supported. Yeah, alright. Basically all there. FMA is actually somewhat useful for linear model runs and quantitative finances, although there's different precisions from what you get with normal SSE multiplication and addition. Yeah, and the fused multiply add is just for floats too. Like, you don't even need fused multiply add if you're doing integers. I don't know why it didn't show up there. Is it? Wait. Is it actually under AVX? Is it not? No. Okay. Wait, I'm so confused. Why didn't that show up before? Oh yeah, so if you have SSE2, you can do fused multiply add in SSE2 of 16-bit integers into 32-bit integers. And this is actually what the, similar to what the AVX512 neural network is looking like, this BNNI. Does a similar thing, but oh my god, these AVX512 instructions are ridiculous. I took some loss forecasted model once and rewrote it in C++, and that thing ran like 15 times faster. Yeah, it can do that. It can definitely do that. Alright, there's that example done. What to do next? Which one to do next? I think we might do reflection now. Oh wait, actually to do the reflection one, I kind of want the stream to be available to do reflection so that we can show serializing using a reflection. So that would mean the stream example is almost like a reflection example too. You know what, let's just do the multi-threaded array example to begin, because that one I'm not unsure of. We're just going to show how to add and remove items while we're iterating through the array. So I was looking around too for how should I document this stuff, because I'm trying to comment this stuff properly now, like full comments and explanations of everything, and I've just said screw the proper C, the supposed C naming structure of everything being undercase with underscores, and I'm just saying screw it. I'm doing the style of Java and C# with capitals because I like, oh my god, it's so much nicer on my brain. So basically, I've just started making this engine where I'm just going to do it the way I think is best. But besides comments, I've been looking at like documenting it, because obviously there's Doxygen where like you go through and you go summary and you write like a whole other documentation, but I'm obviously not going to do that with, like, the ideal thing for me, I believe, would be just to take these comments. And also, I previously ran my other engine through Doxygen. I ran Strand engine here through Doxygen. I ran like 40 files, 40 header files through Doxygen. It gave me this massive list of functions. Horrible way of doing documentation. It was easier to just go through the files and look at the functions. So I'm really lost on what actual organized documentation would be for C, because I've Googled and like, first of all, Google sucks these days. I can't find nearly as much as I used to, but my god, there's like no, if you search up C documentation generators, you get all C++ documentation generators. And it's not the same thing, because it's like Doxygen, where it relies on, the way it organizes it is you having different classes and namespaces, but in C you've got none of that. So I almost feel like so right now I've just concluded on documenting it so that you should be able to just go through and read the file and then I've been thinking about this. There's really no way to understand things like macros besides looking at what the macros actually do. Besides like a little thing that's like aligns memory on the stack, but like to know what it really does, you just look at the code. So I almost think like the best way isn't even documentation, it's just having source code that you can easily trawl through and read the description of. And that's also part of the idea of these examples, is just having starting points of how to use everything. Alright, I don't know what I'm going to do for this multi-threaded array example. I know I'm going to add and remove objects, but I'm not sure if I'm going to make it a string, if it's going to be an array of pointers. I'm probably going to make it an array of pointers and strings, I think. One style of the Unix style man pages. Yeah, I was actually looking at man pages this morning. Unix, I gotta close this. Unix man pages from C code comments. Is there a way to generate man pages? Auto-generate man page from C. There has to be an auto man page generator. Oh, can Doxygen do man pages? Oh my god, so this is the exact same thing. Oh, yeah. So it still doesn't solve the problem of Doxygen just gives you this giant list of functions. And like, yeah, each function has the documentation or like description. So like, here's part of my issue with Doxygen. First of all, it doesn't just take the code descriptions here. It doesn't properly support macros. And so you need to end up writing separate Doxygen documentation or convert all your comments into XML, like summary, things like that. And then it just gives you a giant list of functions, so it's not organized. Yeah, so I think I'm just going to add C strings to this. Create new multi-threaded array. I wonder if I should call it multi-threaded. Of pointers. We're just going to make it multi-threaded, because why not? I think Doxygen requires these .jock style comment blocks, but you can do things like include tables and links. Yeah, I know Doxygen's super powerful like that, but that's my whole thing, is I don't want to put in a whole bunch of extra work just for Doxygen. Like, I almost want to make my own documentation generator that just takes it from comments and sorts it by files. Also, so now that there's GDPR, did you know Doxygen isn't GDPR compliant? It's just a little thing that like no one fucking realizes right now. Doxygen puts up cookies on your site, and a whole bunch of people just have Doxygen on their site with no pop-up saying, like, part of GDPR and the new EU data policies is you need to have a pop-up saying we're storing cookies, yes or no. Doesn't have that. It's really small and you can add it yourself, but like no one realizes that. I think they'll probably fix that soon, or it might even be fixed now, but like when I was looking at that, like, why can't the browser do that? And everyone, well, that's the whole thing that's ridiculous about these laws, is you can turn off cookies if you want. Anyone can do that. It just means that the majority of websites won't work. So this is like, I normally don't talk about laws and things, but I think things like this, where it's the option between having the freedom for people to make the stupid choices of having less privacy, and like, basically if you have the option between having the government say no, people can't have any cookies, or like, man, it's hard to explain, but it's basically like, if people already have the freedom to protect themselves there, I don't think you need to make laws saying to force people to put these protections in place. It basically just puts like something that slows down everyone else who doesn't need those protections, or doesn't like, it's yeah. What are we gonna do here? We're gonna add some strings to it. Add C string pointer to array. I don't know what I'm going to do for this example. So basically what I need to do is, the main part of this array is you can lock the array and loop through it and make changes to it, and then it'll queue up changes and apply them when you unlock it, so you can loop through it safely and do like any sort of multi-threaded access safely. I'm not sure how to show this in a single thread though. Like, I almost don't think I can show it. I almost feel like I just have to show like a normal array feature and hope, and just expect people know why they need a multi-threaded array. I think it's an actual problem, but politicians do something. It would be hard to build a cookie filter that drops hostile cookies, but that's the thing, it's engineering problems. Yeah. Oh, that's my thing, is like, I'm like a minimalist. I'm not necessarily a libertarian, like I believe in healthcare and all this stuff, but like, I think it's like the government should intervene where things are getting serious or extreme otherwise. Like, if tons of people are having health issues and there's no healthcare, the government should probably help out there. Or like, if tons of people are having mental health issues and there isn't like enough support for that, like the government should help out there. But like, stuff like that where it's not like, basically when it rises to become a problem. But like, I'm gonna be honest, I don't think like hostile cookies or people tracking information isn't a problem. Like, the problem isn't the cookies so much tracking you, because majority of people who become aware of this quickly turn on ad blockers and have other ways of blocking these things. And like, the issue really isn't like it's you sending out your information there. The issue is the people not realizing that the programs they're running on their computer is sending out their information and making them available in the network, like not realizing the effects. And like, I don't think we should, that's the whole thing, is it seems crazy to me to put up these safeguards for everyone just because a few people are vulnerable. But I don't know, I guess this is starting to argue if the ends justify the means, and that's a whole rabbit hole. I'm just wondering what I want to test here. People need to learn how computers work. No laws can really circumvent that. Yeah, I've said this whole thing too about how like, oh man, it's not related to computers, but like, you can't protect people from stupidity. Like, as many fences and walls as you put up to stop people from like walking in the road and things, they could just fall over and bash their head. You're never going to stop people from tripping over their own feet. I'm not saying it's not a horrible thing that people hit their head and hurt themselves. I'm just saying there's literally nothing you can do. Which is very harsh, but I think it's something you need to look at and not ignore. So I'm thinking, I've actually got a pretty good idea for this now. We're going to create 3 different C strings. I guess I'll just do 1, 2, 3 to begin. And we're going to add them in order and then remove them in order. Now we're going to put these in an array. I can't remember, I think there's actually a way to get the number of C strings from this if you do like size of array. I'm just going to do num strings like this though. We're going to add the C strings to the array here. String pointers to array, not C strings themselves, the pointers. Just to be clear. Alright, and then while looping through, loop through each C string. Loop through array and remove entry. This lock function is what makes it loop properly, not actually remove or make the changes while it's looping. Through array, print C string, and remove each entry. Now we're going to make this into 8 just to be extra pedantic. String number 0. And then we remove it. Print size of array. Show elements removed. Actually, I don't know if I need to do that. I think this just shows it off, actually. Like I said, it's really hard to explain why you need a multi-threaded array. like, you can't really explain why you need something. People almost need to like come upon that themselves of why. Oh, this is based on buffer.pointer. Alright, let's see. I'm interested if this is going to crash or not, because I actually haven't tested this multi-threaded array. String 0, string ABC, yeah, okay, it worked. We are strings. There we go. Alright, multi-threaded array example. I think we're almost at the point where we're going to code the next part of the stream. We're going to start doing that. So I don't know if, man, let me actually look and see what could I do for the reflection without outputting it to the stream. I guess I could just show getting the types. Yeah, I guess I'll just show getting the types. You know what we will do? Just a simple reflection example. Alright, so we're going to create a little dummy class called like human, something like that, and we'll create some variables that we then reflect and we output those here. So let's see, I just basically want to show different types. Age, height, name, and we're going to use buffer. This because that's what I want to test. The buffer is how the reflection stores arrays of memory. Human structure. Reflect fields from human struct. Birds flying high, you know how I feel. Hold on, what is this? Where did we get to this song? It's a new dawn, it's a new day. Alright, so we've got these macros to help with reflection. The core of it is just defining these reflection and field reflection structs. So that's what the macros just do, is set up the structures for you. So yeah, we should just be able to type new reflection type now. Actually, do I need to put anything else? Just count. Then here we do reflect to reflect a normal structure, reflect B to reflect a buffer. So then the reflected buffers still have a type. So in this case, the name's going to be a unit 8. That'll work. Yeah, so I haven't actually done this yet, so this is good. I'm typing this stuff out. So then we have to do that for... yeah, just all of them. Unit 32, age. So the reflection is manual. You have to type out the field definitions again. But this is also kind of beneficial in a way, because if you don't want things reflected, like if you want to strip the names and don't want all your variable names in strings, then you can do that. Alright, create, construct. Buffer string human. What's a name that actually sounds robotic? I'm just gonna name it Ron. And age is gonna be 64. Height is going to be 5'4", and then we're going to print out data about human using reflection. So we could actually, so this is actually a way to show reflection here would be to have two different fields here. And show how you can just print out any data using the reflection. Function for printing structure using reflection. Reflection type. I'm going to do print struct like this. And the reflection type is going to be reflection type human. Like that. There we go. So now we just need to write our function. So if we look at the reflection type here, it's an array of fields, and then the size, which is the number of fields. Now that I look at this is basically a buffer. Oh my god, this is literally just a buffer. Oh my god. Well, whatever. is a structure, so print the field, print field name. Print different types. Or what we're going to need to do is check which type it is. Print type. If base type collection base type struct so we're not going to do recursive printing here. So basically, what we could do here is we could actually call the print struct function again, because the reflection types can actually reflect other types. So we're not going to do that. Oh my god, birds keep flying on my roof right outside my window, and it freaks me out seeing something moving really fast outside the window. Or the base type, the buffer or array. If field type fields does not equal null or equals null, because if it doesn't equal null, then it's not a base type that we can print. If field type equals so we actually just need to check whether or not it's a float or double. The float. Otherwise we're going to print an integer. Equals reflection type float. Then print float. Oh yeah, and we need to make this a int8 pointer so we can apply the offset. Just like that. Oh yeah, we're actually, never mind, we're gonna need to check all the types. Because it's going to depend how we read it. Else if field type. So we're just going to support int32 and float for the simplicity of this example. And then this buffer is going to loop through the buffer. build type equals reflection type uint8, just making sure all the types are correct so that this doesn't crash. Then we're going to print this buffer as a string. Build type. Float, print int, print string, 8 pairs. Okay, that should be it. Let's try this. C requires the structure union has at least one member. Oh, buffer actually isn't, buffer's not included in reflection. Forgot about that. Initializing different const qualifiers. What could that be? Ooh, what's it doing here? Function incompatible types human uint8. I just want to fix all of these. I'm also doing this thing where each of these examples has to be perfect. Different const qualifiers. Oh, I guess this is, yeah. So then what is the I think it's the reflected buffer right here that's different. Could have different const qualifiers here. Because these are all struct initializations. Aren't const qualifiers in like function calls? String length and size of. Size of doesn't have const qualifiers, does it? Maybe it's this? Hold on, let me try something. First of all, let's try removing all of this reflection except for one. Might be right here. No. Size of n right here. I'm honestly so confused. Maybe let's just try disabling these as we go. We'll see when we disable one if it takes away the issue. Oh my god, you know what? It might even just be this declaration right here. Ooh. Ooh, maybe it's this. Yeah, so if it happens with no reflection calls right here. Yeah, okay, I 100% think it's like right here. Yield reflect. Just casting this to void, maybe? Oh my god, literally just casting that to void. The warnings in C are so ridiculous sometimes. But like, let's deal with it, because why not? Alright, see how this works? Initializing different const qualifiers. Interesting. So it still happens here. No, they all have it. So, which one is it? Which one has this const qualifier? Taking away all of them except for one, so I just need to change one at a time. We're going to do the exact same thing we did before. Disable these. So we get the one that has the same const qualifier. Oh, it was that right here. Just casting the void should fix it. Yep. There we go. Okay, now let's see if the reflection itself actually works. So this is actually super useful code right here. Mapping out the structure, and then being able to do stuff like loop through all the fields and print it out. Name, Ron, age, 5. So it did everything right except for age. Oh, because this was a unit 32 instead of unit 32. So if nothing happens, we're still just going to print a new line. Everything works fine. There we go. Name Ron, age 64. Okay. So now we're going to create another structure so that we can show how this can easily be used. Find dog struct. I don't know how, I'm gonna have a name. I'm gonna have age. I don't know, I'm not gonna do height. I don't know how I'm gonna do this differently. Weight. Maybe birthday, I don't know. Actually, you know what? I don't think we need to do this twice to show it off. I think this is enough. In one. I gotta consider as well, it's a million times better than not having any examples. Just having this code as a starting point. Alright, now I think we're actually on to working on the stream reflection. Yeah, I think we're just gonna write this stream serialize function out. I'm gonna get up and get some water and take a quick break though. I think for like an hour now. I will be back shortly. You know what, one thing I've been thinking of doing now that I have this audio visualizer, so that it's just sitting on a blank screen, I can put up the audio visualizer and keep that running. Alright, I will be back shortly. Okay, this doesn't make any sense. Wait, look at how bright my camera is. It's like an overcast day outside. And it's so oversaturated. What? Come on, Logitech. Fix your color balancing. Yeah, so it's actually... Okay, so this is supposed to be following my face. Oh god, it's so bad. This is the issue, whenever I try and do this color balancing on my own, I just change the settings manually. Can actually get it looking pretty balanced like this, and it's actually higher frame rate. But the issue is it looks bad when it gets dark. Hold on. Actually, you know what? That isn't too bad. I don't understand cameras. Who knows? Anyways, let's so I've been thinking about this. I don't know if I want to write for the stream example. I could just set it up to output to both a console and a memory stream. I don't know though. Yeah, so one of the things I've also been thinking about making, I'm not sure if I'm going to, is a multi-stream. So you can basically output to like a memory stream and a file stream at one time, or if you want to output to a console and a memory stream. And I think that would maybe make a good example. I don't know. I'm just thinking though, I think if I'm doing this structure serialization, I'm gonna need to test it. And that would be a good example of the stream. I think we might do that. So right here, the serialize base function I was going to write, called base because it was going to be recursive. It's going to be just called serialize. But anyways, I was planning to print out the field names and basically try and make this system where it would render out, or it would put out binary onto the stream and then be able to load it up into the type and try and load it into the most compatible field. Like even if you changed the field type, it would like convert float to integer. And this, planning this out, like this is just the beginning. This doesn't even like really do anything. It would have been massive doing this system to try and convert between all of these and basically make an interchangeable binary format. And basically what I ended up coming to the conclusion is I'm just going to be making a JSON parser and serializer. It's just way easier if I just made a thing that converted from reflection to JSON and then serialized to JSON, and then that does like basically the exact same thing. Even better, even because of the way like string formats work. So then I've just decided to go full in fixed binary on this. So we're just going to make actually what this is end up going to be is a stream serialize function that just does a fixed binary serialization of a type using reflection. So this will be like really good if you're trying to send over packets to a server or something, where you now can just type out your packet as a structure and send it over with reflection. And the main thing it'll do is automatically swap endianness if it's needed, things like that. Yeah, this is actually going to be a pretty big function we're going to write here, but I think we're just going to dive straight into it. I'm just going to leave this old function I was writing down here as sort of a reference. I need to think about this though. Well, yeah, this is the issue, is my brain starts thinking about multiple of these things at one time. So I'm also thinking about that this serialization is a really good example for the stream and the reflection. So I think I might do that, like a mix between the reflection example and the stream example. I don't know if I want to go straight into this example yet. Hold on, I will be right back. I'm sorry, but I think that's going to be the end of the stream for today. Oh man, I am not focused on this, so I am... this is actually tend to be something I do. If I am not focused in on a project and I'm jumping between things, I'll just generally move on, go and do something else until my mind is in the place to do that. Like, basically, I think it's like a waste of time if you spend a lot of time trying to do something at little efficiency, when if you wait a little bit later, you'll be doing it at higher efficiency. Anyways, you know what? I might get my, I might do my daily GLSL shader right here to get that out of the way for the day while we're here. I mean, why not do that? Yeah, let's do our daily GLSL shader. Also, let's brighten this up a little bit. There we go. Okay. This was our shader from yesterday, Shadow Pool. I'm not sure what I want to use as a starting point today. I don't have any plans for the shader today, so I kind of like this inverted coloring scheme. Alright, here's our blank UV shader to begin. What to make? What to make? I might try and do different vortices. Might do a black and white one, I think, again. Alright, there we go. That is our checkerboard pattern. Oh wait, never mind. Oh yeah, it's mod apps one. Did I forget? I think I forgot how to do checkerboarding. Oh no. Oh, they're supposed to be floored. There we go. Alright, so the plan is to do some vortices that distort this and rotate it. So we're going to generate random points with the hash. And we're going to rotate this around those points. Find variable RP, oops, instead of LP. I can actually do this in a single line. And this position should be scaled up by 10. Time. Oh, that's not relative. Oh, okay. So I do need to do it before for that. Let's do log scaling. Alright, so there's one vortex. It actually has more distortion in the middle. Oh man, I wonder, is there a way we can increase the rotation amount? As it gets farther away. What if we mix this? I've never really tried mixing 2D matrices before. So if we did a whole rotation of 1.6 and mix between that and no rotation. Unable. Oh, can't mix between that too. Oh god, what is... Oh. Yeah, I can't think of any way to actually make it move differently. Okay, now what if we try this in the middle, so it makes it slower? Yeah, no, you end up with inconsistencies after a while. Well, I guess that's the way it is. Alright, let's add some randomization to this from the hash. And now let's see what it looks like with multiple distortion points. Oh, the points are not far enough range though. Now they are. Oh, this is gonna be crazy. So the points end up rotating around each other. Oh god, this is gonna be nuts. I should probably do another pattern beside the checkerboard pattern too. Anyways, let's add more. Looks like it's going off screen. I think it's... Here, I guess they're rotating each other off screen. What if we actually had this decrease as the length goes down? Yeah, I'm actually going to try making the distortion go down over the distance. Yeah, if only there was a way to make the rotation Yeah, because this keeps stretching. What if we did 1 divided by length here? There we go. Yeah, so we almost need it to like loop around there. Actually, wondering if there's a way to make this loop. But I feel like there might be. Ooh, that's nearly looping, it looks like. There has to be a way to do this. Maybe if I applied an anti-rotation. Yeah, that cancels it out. No. Oh, something's happening there. Oh, so now that's rotating correctly in there and is stretched right there. So we can actually rotate correctly within an area. Okay. I wonder if there is a way to fade it out smoothly. Now it starts stretching unless we can somehow match those back up.
His name, I thought I'd come by, see him again. When you two dance, oh what a dance. When you're too loud, oh what a love. Does he mention my age, love? Or is he more into young girls with dyed black hair? I'm in love with you, brother. I thought I'd come by.
I wonder if I can have it slow down as it matches the beginning again. I could definitely do that with a triangle wave. Try a whole bunch. I think we can also do this all into one rotation. So it doesn't distort outside the grid. Anyways, let's add the slowing.
One day, he'll die. But let me ask you something. Are you living now?
I'm
Yeah, how can I get it to change speed or time?
Don't be afraid. One day, one day, you'll die.
Oh, there we go. That slows down. Try without the cancellation. Now it's going to have different rotation amounts for each. Oh, we could actually do opposite. Oh yeah, we could do opposites here. So some rotate one way, and they should actually end up canceling out. What happens if we just do 100 of these? So I think these points should be rotating around each other. I'm not sure. I wonder maybe if I should put some indicator of where the circles actually are. What if we just kept them static and didn't rotate them around each other? Yeah, it shows up as distortion. Yeah, that definitely doesn't look as good. What if we just had the count increase over time? Now it's adding more as time goes on. It gets more and more chaotic. As you can see, spinning all over the place. They affect each other, and they actually get out of range and invisible because they're moved so much by each other. I'm just gonna call this one disorientation. And I'm gonna include anti-aliasing for this one, I think. Alright, and then we gotta divide S by the number of anti-aliasing samples here. So that is gonna be AA times 2 point plus 1 times 2, or the power of 2, multiplied by itself. Their unexpected token. Oh, there we go. So now that's got 2 times anti-aliasing. It's very nice. Let's see if we can toggle it on and off. Yep, okay. Alright, there's our shader for today. Disorientated. Let's capture our animation. Oh no, it's capturing at 50 frames a second. There we go. Oh my god, FFmpeg renders out such nice videos. Like, it's basically perfect. Alright, now let's render the wallpaper version. Oh my god, staring at this actually breaks my vision a little bit. Go and turn on the anti-aliasing for this. Check out this anti-aliasing. Oh my god, that doesn't have anti-aliasing. Hold on a second. There we go. Now it's got anti-aliasing. Alright, there's the shader for today, Disorientated. That'll be the stream for now. So first of all, you missed any of the stuff yesterday. We finally released Strand Engine, the collection of C code that I've been programming for like years now. I stopped working on it, so I just decided to push out the code in the unfinished state. The download on the Discord and everywhere. I also released Shader View, the music visualizer and shader viewer I use for these streams. So if you're interested in any of that, that stuff's up now. Yeah, I hope everyone has a good day. I will see you all around. If you're interested in the wallpaper version of this, or the video, it's up on Twitter now. See you around. Have a good day, everyone. Bye-bye.